We often think about connecting to the internet using a local wireless connection or a wired Ethernet cable, but you can also connect to the internet using satellite networking. This satellite connectivity communicates into space to a satellite and back down to Earth again to provide your internet connections. This is a relatively high cost because of all of the equipment that's required to get this working, but you can get relatively good bandwidths. For example, it's very common to see 50 megabit download speeds and 3 megabit upload speeds. We're seeing some changes with this technology. As Starlink is being rolled out, we're seeing those speeds beginning to increase, and you may see that satellite networking becomes much more common in the future. If you have a remote site or a site that has no other option for connectivity to the internet, satellite networking may be the perfect solution. Because of the type of communication where we're communicating up to a satellite and back down again, we tend to have a lot of latency with this connection. Historically, we've seen latency up to 250 milliseconds as traffic is going up to the satellite, and another 250 milliseconds as the traffic is sent back down again. The newer technologies from Starlink are promising to lower those latencies down to 20 to 40 milliseconds. These are also using high frequencies, usually 2 gigahertz frequencies, which means that they are subject to being absorbed by anything that may be in the way, specifically rain showers. And this is where satellite networking has problems, is during a rainstorm, you could lose connectivity to that satellite. On most of our Ethernet networks, we're using copper to connect our devices together. These are relatively inexpensive to both connect inside of a building and between locations. But because it's copper, it has a limited amount of bandwidth that we're able to send over this connection. When you need higher speeds, you usually don't use copper and instead use something like fiber optics. But these are very common to see on wide area networks, especially wide area networks coming into our home. You often see cable modem or DSL connectivity, and those are usually provided over a copper coax connection or a copper twisted pair connection. There's usually a combination between copper and fiber that we might use, where we would have copper on what we call the local loop or the connection into our local facility, and within the provider's network, we usually would see fiber optics. One of these copper connection types is DSL, or digital subscriber line. Often this is actually ADSL, for asymmetric digital subscriber line, because the speeds coming into our homes are different than the bandwidths and speeds available going the other direction. Therefore, it's asymmetric. DSL uses the telephone lines that we already have inside of our homes and businesses to provide this connectivity. With DSL, there's usually a limitation distance. For example, there's usually about a 10,000-foot limitation between your location and the CO, or central office. In many DSL connections, you'll see downstream speeds at about 200 megabits per second and upstream speeds at about 20 megabits per second, but these can differ depending on the type of DSL technology being used in your area and how far away you might be from that central office. One of the other popular copper connections for internet connectivity is a cable modem or cable broadband. We call this broadband because the signals inside of that coax connection are being transmitted across many different frequencies or a broad number of bandwidths. There are many different traffic types usually inside of these coax. There may be digital television, internet connectivity, and voice. You may notice that the specifications for your cable modem have a specific standard called DOCSIS. This is Data Over Cable Service Interface Specification, and this is the type of connectivity that is used by this cable modem. Depending on the DOCSIS version that's being used in your cable network, you may see speeds that range anywhere from 50 megabits per second through 1,000 megabits per second or 1 gigabit per second. One of the fastest ways to communicate over our networks is not to use copper at all, but instead to use light. This is fiber optic connectivity, and it provides some of the highest speed networks that we use. This higher speed, though, comes at a cost. Fiber networks are generally more expensive to implement than copper-based networks, and certainly more difficult to repair. You have to have specialized equipment and personnel to be able to repair breaks on a fiber optic network. But this does allow you to send a lot of data over a very long distance, making it perfect for those wide area networks. It's very common to see internet providers and wide area network providers use fiber in the core of their network because it does provide so much speed and so much bandwidth over a long distance. This is where you would see things like SONET rings and wavelength division multiplexing, or WDM. But you might also find that fiber is finding its way to your home. Many organizations are putting fiber into the ground and to your house, providing bandwidths and capabilities that we simply don't have on copper networks. If you're part of a company that has many different locations in a single city, you can usually connect those together at higher speeds using Metro Ethernet, or Metro E. This is a type of connectivity that's usually within a very small geographic area, but it does allow you to connect those locations using very high-speed networks. Another nice part about Metro Ethernet is that it is Ethernet. At both sides of the connection, the provider simply hands you off an Ethernet connection that you can plug into a normal Ethernet switch. Inside of the provider network, of course, it's usually some type of higher speed connectivity over fiber optics. So it's very common for the provider to use wavelength division multiplexing or SONET rings inside of their network, but what you see on your side is simply an Ethernet connection.